data structures and algorithms, how it is going to help us to develop logics of data science applications. What are the logics we are going to study under data structures and algorithms? So this is the syllabus we are going to see today. 14 topics like introduction to data structures, stacks, queues, linked list, trees, hash tables, search algorithms like linear search, binary search, sorting algorithms like selection sort, bubble sort, insertion sort, divide and conquer like Mergesort and Quicksort, introduction to graph theory, basic graph algorithms like BFS and DFS, traversals and shortest path. These are the 14 topics we are going to see today. So what is meant by data structures? Data structure is a systematic way of organizing data and representing data and storing the data and retrieving the data in the fashion of linear. That is called linear data structures. Examples: arrays, stacks, queues, linked list. These are the examples of linear data structures, because linearly we are performing all sequential pattern, we are performing all operations, and a systematic way of organizing data and representing data and storing the data and retrieving the data in the fashion of non-linear fashion. That is called non-linear data structures. Examples are trees and graphs. Those are the major concepts of major types of linear data structures and non-linear data structures. So coming to the first topic, programming. What is meant by programming? So collection of instructions, and we are developing an application, the process of designing and writing and testing and debugging and maintaining code that computers can execute. That is called programming. What are the concepts we are using under programming? We are using used to solve various problems and automate tasks by using languages like Python, Java, C++, JavaScript, etc. And types of programming languages like procedural, like C programming is a Fortran is a procedural, and C language also procedural, and object oriented like Java and C++, even Python, functional like C language and other Lisp and Prolog, scripting like JavaScript, etc. Even Python is a scripting programming language. And examples of these programming languages like we are writing a script and scrape data from a website. లేదు, అది స్విచ్ ఆఫ్ అయిపోయింది, బయట భోజనానికి వెళ్ళినాము. ఇప్పుడు క్లాస్లో నేను క్లాస్ అయిపోయిన తర్వాత కాల్ చేస్తాలే. లేదు లేదు లేదు, అది స్విచ్ ఆఫ్ అయిపోయింది, బయట వెళ్ళినాము డిన్నర్ కనేసి. ఓకే, మళ్ళీ చేస్తాలే క్లాస్. So these are the examples: writing a Python script to scrape data from a website. So that is about a first programming concept. If you see the introduction, second concept, introduction to data structures, I have explained data structure is a systematic way of organizing data and representing the data and storing the data and retrieving the data in the fashion of linear. It is called linear data structures. Examples like arrays, linked list, stacks and queues. Whereas non-linear data structures like a systematic way of organizing data and representing the data and storing the data and retrieving the data in the form of non-linear, it is called non-linear data structures. Examples like trees and graphs. So using an array to store student grades, it is a best example for performing static data structures like arrays example, Dynamic data structures like linked list, trees, graphs, stacks, and queues, etc. Then the third concept is stack. What is meant by stack? Stack is a linear data structures and follows the last in first out logic, and it is used in various applications like undo operations and parsing expressions and conversion of expression into trees, trees into expressions, etc. Types like array-based stacks implementation and a linked list based implementation. Examples like managing undo operations in a text editor. That is called stack operations like push, pop, and display, etc. Then a fourth concept is queues. Queue is a linear data structures and follows the principle first in, first out data structures. The concept is used in scenarios like task scheduling, printer, print queues, etc. There are various types of queues like linear queue, circular queue, priority queue, etc. And examples like task scheduling in an operating system, that is called linear data structures, I mean queues. Then fifth concept is linked list. There are drawbacks in arrays like arrays are fixed size, arrays are static data structures, arrays are same type of elements we are storing. Arrays has high memory wastage and insertion deletion very tough while performing arrays operations. That's why we are going to perform linked list concept. So in order to avoid the drawbacks of arrays, we are using linked list concept. Like a data structure consists of a sequence of elements. Each element points to the next one, unlike arrays. So types of linked lists are single linked list, double linked list, and circular linked list. So linked list is a collection of items and connected by the links in one direction is called a single linked list. And single linked list operations are insertion, deletion, display, etc. Then a doubly linked list, a collection of nodes and connected by the links in both direction like forward direction and reverse direction. That is called a doubly linked list. Operations like insertion, deletion, display, etc. Then circular linked list, collection of nodes and connected by the links. The last node is connected to the first node is called circular linked list. And node is a combination of value and address. And there are two types of links, like one way that is called forward direction and two way is forward and reverse directions. Then example like a music playlist where each song points to the next song, that is called a linked list. Then trees. Tree is a collection of nodes and connected by the links. The last node is connected to the first node. And the trees like a root node, collection of nodes and connected by the links in a hierarchical manner. That is called trees. There is a root node, there is a leaf nodes, there are internal nodes, there are external nodes, and a node is a combination of value and address. It is a hierarchical data structure with a root element and a subtrees. Concept like used in databases, file systems, and sorting algorithms, etc. There are types of trees like binary trees, AVL trees, and B trees. Binary tree is a tree having at most two children. That means 0, 1, and at most two children. That is called binary trees. And AVL tree is a Adelson Welsky Landis. A stands for Adelson Welsky Landis. Three scientists has been proposed by AVL trees. AVL trees are binary search trees. Binary search tree is a tree. The root node is always greater than the left subtree, and left subtree is always less than the root node, A right subtree is always greater than the root node. That property is called BST. How can you justify BST is the constructed BST is true based on the tree traversals like in order, post order, pre-order and level order. If you perform in order traversal, the elements are in a sequential manner. That's why we can justify that the constructed BST is true. That is, AVL tree is a one type of binary search tree. That means the height of a root node is equal to left subtree height minus right subtree height. That is equal to 0, -1, 1. If it satisfies that property of any node in the tree, that is called AVL trees. Adelson, Welsky, Landis. Then comes to the B tree. B tree is a balanced tree. Most of the people believing that B stands for balanced. So B tree is a type of binary search tree. Left subtree is always less than the root. Right subtree is always greater than the root. So there are few more properties of B tree. B trees are usually used in the databases in order to efficient memory utilization and in order to retrieval the data, insertion of the data, etc. Examples of B trees like organizing folders and files in a file system, that is called trees. Then come to the hash tables. Hash table is one of the special concept in data structures. Hashing is nothing but the process of mapping key with value in a hash table. The process of mapping a key with value in a table, two elements are competing hold a same bucket. That situation is called collision. To avoid the collision, we are using collision resolution techniques like addressing, chaining, chaining addressing method, open hashing, quadratic hashing, double hashing, etc. So hash table is a data structure for fast data retrieval based on the index position. The concept is used in hash table is hash function to map keys to indices, means index positions in an array like A of 0 first position, A of 1 next position, A of 2 third element, A of 3 fourth element, and so on. Array index starts from 0 to n minus 1. Same way, hash table index starts from 0 to n minus 1. There are types of hash tables like chaining method, open addressing, quadratic probing, double hashing, etc. Examples of hash table: sorting and retrieving phone numbers by name. That is called hash table. Then eighth one is a search algorithms. Searching is a finding a element in the given database or searching for an element in the database. A search algorithm that finds the position of a target value within a list is called a search it is called searching. Concept like it sequentially checks each element until a match is found. So there are types like linear search, binary search, etc. So so types you can call it as a linear search, binary search here. Linear search. Sundar, are you understanding? Any doubts,
Yes,
please
yes,
ask me.
yes. You kind of refreshing my 95, 96, my school syllabus. So
That's
it's
great.
more than a 25 years, so I'm enjoying it.
Yeah. I can understand the way you are grasping the knowledge. Already you have a tremendous knowledge. Now you are listening and enjoying the concepts.
Yes.
Yeah, types
But
of
some of the
yeah,
things I forgot, but you've been refreshing my memory. I think
yes.
you're in a
That is the
great
reason. Yeah.
you are in a great right path, doctor. Go ahead.
Thank you so much. So there are two important searching algorithms like linear search. The time complexity of linear search is order of n. That means the searching element in first position, the time complexity is order of 1. The searching element at middle position, we can call it as order of log n. If the searching element at the last, we can call it as order of n. So sequentially we are searching the elements in a database is called a sequential search or linear search. So it takes time of n number of elements. It takes a order of log, I mean order of n. So if you take binary search algorithm, the procedure we are following. So first we are finding the mid position of a given elements. Like how do we find a mid position? Mid is equal to low plus high by 2. We are getting the mid position. The searching element we are comparing with mid position. If it is less than the mid position, we are leaving upper bound elements and we are searching only in the lower portion. If the searching element is greater than the mid position, we are leaving the lower portion and we are searching only half of the portion of the upper position. So that's why binary search tree is a better than linear search. The time complexity is order of log n. That means half of the time we are reducing comparatively linear search. So that's why binary search is a wonderful searching algorithm and we are using wherever it requires. Example, finding a student's name in a list of registered students. So by using linear search, binary search, we can perform it. The ninth concept is like a binary search I have explained, like a search algorithm that finds the position of a target value within a sorted list. Concept is it repeatedly divides the list in half until the target is found, like iterative search and recursive search. Example, finding a word in a sorted dictionary. So then 10th one is a sorting algorithm. Sorting means arranging elements in a sequential order by using selection sort, bubble sort, and insertion sort. Definition. So algorithms to sort a list of elements by using various kinds of algorithms. They arrange elements in a specific order like ascending order or descending order. So like a types in place algorithm, not in place algorithm, like depends on our user requirement. We are choosing the sorting algorithms. Example, sorting a list of numbers from least to greatest. Then the 11th concept, divide and conquer approach. Data structures, usually there are 4 approaches like divide and conquer approach. Here we are using Mergesort and Quicksort, and dynamic programming and greedy approach and branch and bound approach. In dynamic programming, we are using a traveling salesman problem, and you can see the greedy approach 0 by 1 knapsack problem, and branch and bound we are using chess 8 queens problem or chess program, etc. So under divide and conquer approach, that means we are dividing the problem into sub problems. So then we are sorting the each portion and we are merging lower portion and upper portion and making a merge sort. So the time complexity is order of n square, and the best sorting is order of log n. I mean order of n square is the time complexity of merge sort. Then quick sort. There is a procedure in the quick sort we are following, like left side I with j. So we are selecting one element called pivot. Pivot we are comparing with I with pivot left side and right side j with pivot. That means quickly left side I with pivot element, right side j with the pivot element at a time. From both sides we are sorting the elements quickly. That's why it is called a quick sort. It is the best sorting algorithm. Like in searching we have a binary search, and in sorting quick sort algorithm. So the best time complexity of quick sort is order of n log n. So the definition, algorithms that divide the problem into subproblems, concept like solve each subproblem independently and then combine them, merging them. So types, you can use a recursive method. A recursion is nothing but the function calling itself. That is called recursion. So compiler feels risky while performing recursion. So that's why maximum time we are avoiding recursion concept. Then examples like sorting a list of numbers using Mergesort. Then you can see the 12th concept is introduction to graph theory. So the definition is study of graphs. Graph is a collection of nodes and connected by the links in a network fashion. Connected network fashion is called a graph. So node is a combination of value and address, and one node to another node we have used arc or link. Then study of graphs, which are collections of nodes connected by the edges. So concept like used in network design, routing algorithms, social network analysis, etc. That's why even best example for graph application is a Facebook application. Now I would like to find out how many Tamilian people are there in USA. I'm connecting one node to another node. Likewise, I'm creating a graph. So that graph is a one type of application in the graph theory. Then the types of graphs like directed graph, undirected graph, weighted graph, unweighted graph, etc. Example like social networks like Facebook can be represented as a graph. Then 13th concept is graph algorithms, very famous algorithms like BFS and DFS. Definition is nothing but breadth first search and depth first search algorithms to traverse graphs. Traversing means visiting one node to another node. That is called traversing. Then our BFS and DFS used to visit all the vertices of a graph. So what is the logic behind BFS? What is the principle behind in BFS? Breadth first search uses first in first out principle called a queue principle. Whereas in depth first search uses a last in first out principle, it is called a stack. So the aim of the BFS and DFS, we are visiting all the vertices of a graph. So then types like graph traversals and shortest path we are using. Examples like finding the shortest path in a maze using BFS. Then programming and data structures and algorithms. There are famous algorithms we are using in data structures and algorithms in order to solve complex applications. By using Python to implement and study these data structures and algorithms, programmers benefit from the languages like simplicity, readability, and vast standard library. The combination of Python with these fundamental concepts paves the way for the development of efficient, scalable, and maintainable software solutions. So introduction to data structures, I have explained. Data structures are foundational constructs in a programming that allow for efficient storage, for accessing the elements, and storing the element, and representing the elements, and manipulation of a data. Python offers a rich set of built-in data types or libraries or packages to support these structures. Then stack is a linear data structures like last in first out. Think of it like a stack of plates. The last plate you put on top of is the first one you remove. Python can easily implement a stack using a list or using collections. DQ for higher efficiency. Then queues. Queue is a linear data structures and queues operate on a first in first out basis. Imagine a line or queue of people waiting at a bank. The first person in line is the first to be served. Python can implement a queue using collections.dq. A linked list consists of nodes where each node contains a data field and a reference link to the next node in the sequence. Python doesn't have a built-in linked list, but it can be easily implemented using classes. Class is a collection of objects, or a class is a collection of methods and attributes. Class is a blueprint of objects, and class has a name. Class has a like attributes, like variables and methods. Methods are also called as a functions, etc. Then you can use this a linked list consists of nodes where each node contains a data field and a reference like link to the next node in the sequence. Like in one direction is called a singly linked list. In both direction we can call it as a doubly linked list. The last node is connected to the first node is called circular linked list. Python doesn't have a built-in linked list, but it can be easily implemented using classes. Tree. Tree is a collection of nodes and connected by the links in a hierarchical structure. There is a root node, there is an internal node, there is external node, and leaf nodes. Then trees represent a hierarchical structure with the most common being the binary tree. Binary tree is a tree having at most two children. It can be a 0 or 1 and a 2. Python can implement trees using classes with nodes pointing to their children. That is called trees. There are various kinds of trees like binary trees, binary search trees, AVL trees and splay trees and B trees, etc. Hash tables. Hashing is the process of mapping with the key with the value in a hash table. So Python's dictionaries are implemented as a hash table. Hash table follows the index position, that is called indices. Index starts from 0 to n minus 1. They allow for the fast retrieval of values based on a unique key. Then linear search, I have explained a simple searching algorithm that checks every element in a list or array until the desired element is found or all elements have been checked. Binary search tree, a more efficient searching algorithm for sorted list. It divides the list in half repeatedly until finding the desired value or concluding it's absent. Selection sort is a sorting algorithm that works by repeatedly finding the smallest element or largest depending on sorting order element and placing it at the beginning. So bubble sort is a exchange sort, a sorting algorithm where adjacent elements are repeatedly swapped if they are in the wrong order. That's why it is called exchange sort. That is called a bubble sort. Then insertion sort, it builds the final sorted list one item at a time by taking one input element in each insertion and placing it at its correct position. Then Mergesort, it is comes under a divide and conquer approach. That this algorithm that divides the list into halves means subparts, sorts them, and then merges the sorted halves. Then the time complexity of merge sort is order of n log n. Quicksort is another divide and conquer approach where an element called the pivot is chosen. All elements are rearranged to make all elements less than the pivot come before and all elements greater than come after. Then it recursively sorts the both sides and both subarrays. It's called quicksort. The time complexity of quicksort is order of n log n. The worst case time complexity is order of n square. Then introduction to graph theory. Graph is a collection of nodes and connected by the edges in a network circuit. So it consists of nodes like vertices and connected by the edges. They can represent a wide range of problems in computer science like computer networks, graphics, and Facebook application, traveling salesman problem, etc. Then the types of graph traversals are two types like BFS and DFS. Breadth first search, an algorithm for traversing a search tree or graph structures. It starts at a selected node and explores its neighbors at the current depth before moving on to nodes at the next depth level. That is called BFS. It uses a queue principle, first in, first out. DFS is nothing but a depth first search. It uses last in first out principle, that is called stack. Another method to traverse trees or graphs, it dives as deep as possible into a structure before backtracking. It can also be used to determine the shortest path between nodes. Then implementation of a stack data structure using Python. So you can use directly class name is a stack. My class name is a stack. Name always starts with class name always starts with the capital letter. So we are declaring my class name is a stack, my function like constructor init, and I'm declaring one more function called push, then pop, and these are the two major operations. If no element is there, that is called stack is empty. Then one more function called peek. Peek says that the position of the element in the list. Then if you are popping all the elements, it becomes empty. You check if the stack is empty, and you are arranging the element. We are test that stack, and if you inserting elements called pushing, if you are removing the element is called pop. I mean pop, and peek means the position of the element. So I'm sharing this code. This is a queue from collections of import DQ. My class name is a queue, and I'm performing the operations like a constructor or a init function. Then one more function called NQ, where we are inserting the elements. Then appending, we are adding the element, and DQ, and we are removing the element. So these are the operations, like we are declaring function called front end. Then we are deleting the element is called rear end, that is called empty. Then we are checking the program. So implement of a singly linked list data structure using Python. So we are declaring my class name is a node, and my function name is init. So I'm sharing this code. Sundar, can you execute the stack principle? Yeah,
Yeah.
I'm sharing. Yeah. Please open
I
your.
can. I can do one, or I can do
You
it
can.
later and send it to you.
Yeah. So one you can execute in front of me so that I'll feel very happy.
Yeah. Absolutely. Absolutely.
I'm sharing this code, and you can execute. I'm sharing through WhatsApp. So, Sundar, code. Write a Python program to perform stack operations. So stack is a linear data structures and follows the principle. You can create a notepad space
Yes.
like stack.py. Then you can perform these operations by using functions. Can I see your screen, Sundar?
Oh, yes, absolutely.
Yeah, I'm stopping my
Yes.
screen. Yeah. Yeah, now it is coming. Yeah. TLS, clear the screen. Can you increase the this command prompt? Control plus you can use automatically. It can increase. Yes, perfect. CLS, clear the screen. Notepad space. Stack.py. Yeah, you can create. Yes.
I did run most of the one that you gave it to me,
Yeah.
but except the problem that I had was
What
the
is the problem?
TensorFlow. I wasn't able to install the TensorFlow.
Oh, sorry. I'll explain. Don't worry.
Okay.
Yeah,
So,
Control S, save the program. Control S. Then go to command prompt, Python space, stack.py. So it is saying that line number 22. So yeah, indentation. So 1 second. Yeah, line number 22. It is misplaced actually. 1 second. I am also executing.
yeah, I know what the problem is.
Yeah. What is the file name? Stack.py. Okay. I am also executing. Perfect. So I'm sharing this code. You try with this one, you will get it. So maybe indentation problem. I'm sharing one more code. You can try this one. Same
Invalid non-printable character.
space tag.py. Second time I have shared the screen. I mean,
Okay.
I shared the code. You copy and replace that old code.
Oh, sure. I can do that.
So that it will not be an indentation problem. So it will execute. Second time I have shared the code.
Yes.
You replace that one and try to save the program and execute.
Same problem.
Same problem? No. Do one thing.
It's coming in the
Oh,
stack,
double quotation
right?
problem. Okay, it is yeah. CLS clear the screen. Maybe output
Invalid non-printable character.
yeah.
Let me,
CLS yeah. Python space 1 second. So
I think
line number
42.
yeah. It is okay, correct. Line number 42, that one. Yeah, 1 second. This is line number 42. It's correct only. Maybe some space. No, correct only. Can you save the you completely you can remove that complete program and once again you paste it. Control A, delete. Again you can copy from the WhatsApp, then paste it.
I did.
Yeah. Then why it is showing error? In my system it is executing.
No, in your system. Okay, let's see. Control.
Yeah, CLS. Okay. Yeah, line number
44.
44. 1 second. Line number 44. Line number 44. No, something in the downstairs you have copied. Once again, I'm giving same
Oh, it's
as
okay.
it is.
Yeah, it's okay. Let me try one more time. Let me delete it. Yeah, like you said, let me delete it.
Yes, correct. Now I'm sharing now that you can take it. While copying, yeah, up to implementation of a stack data structure using Python, you can copy, then perform it.
Up to where?
Yeah, that's fine.
Okay.
Same thing. You copy and paste. Maybe some non-portable characters.
Maybe on the when you paste it, when I take it, might be a issue.
Yeah,
okay.
yeah.
Same thing. Invalid non-printable character. Where is that?
Yeah,
Okay.
I'm sharing my screen. You can see it is. Yeah.
One second.
Yeah.
Let me here. Let's fix it in the line number 43. Let's see what is the line number 43 is.
Yeah, something. Yeah.
Okay. This should go.
Yeah. You bring it to same line. Hash output. You can bring it to right side.
Yeah. Let's see. Let's see if it.
No, because items stack object has no attributes. Self dot items append item line number 9 and 35. Line number
No.
9 35.
Line number 9.
Somewhere else some dot or something has been placed while copying. That is the reason. See, I'm sharing my screen, same program I'm executing.
Okay.
Yeah, see here. I'm sharing my screen. sharing my screen. Same program. See here. This is my screen is visible, Sundar.
Yes.
Yeah, notepad space stack.py. The same program, implementation of a stack data structure using Python. So my class name is a class stack. Everything is perfect. See. So
Yes.
this also same. So just I'm control S. Now I'm sharing just executing Python stack.py. So top of the stack is C, size of the stack is 3, pop item is 2, size after P. I'll do one thing. I'll save this program and share to file as if while copying maybe some characters like space or dot, something it is happening. Let me do it file save as. I can do it. So all files I'm going to download stack.py. I'm sharing the file as it is so that it will execute as it is.
Okay.
Yeah, now I'm sharing with you, Sundar. So a file I'm sharing directly. You can open and you can where your screen, I mean C colon slash some file slash Sundar. There you can paste it directly, this file. Download the file. That file must be in the path, like where Sundar I have seen your screen.
Yes.
In the folder,
Absolutely.
you paste it. Then you can open the file as it is. Open your C colon. There you can paste it, that file, then you can execute. Now I'll stop my screen. Now you can share your screen. Yeah, now, sorry, stop. Now you share your screen. Download that file. Yeah, perfect. So the C colon users and Sundar. So you need to, yeah. Now Python space stack.py. Yeah, now it is running because of that single quote and double quotes and dotted some spaces it is taking.
So
Okay, that is the reason. Okay, I'm switching to concepts now.
Okay, sure.
Sharing my screen. Yeah, you can execute remaining programs. It is very easy. Then I'm moving to as a queue, same as we are performing operations like DQ, NQ, and display the elements. Then implementation of a single linked list data structures using Python. I'm performing like my class name is a node, my functions like constructor called init function. Then I'm adding the operations like append and like some more operations prepend, then display, delete. These are the operations I'm performing. Then I'm printing the list. So stack up, I mean singly linked list operations like append and prepend and print list, delete. So these are the singly linked list operations. If you see the next, that's all. You can try to execute these programs. I'm sharing the PPT. Then can you answer the questions? Which of the following is not a type of data structures? Please quickly remind me the answer.
C function.
Yeah, perfect answer. C is the, it is not a type of data structures. Then which operation is not applicable on a stack? So stack operations like push, pop,
search.
Yeah. You can call it as a search is an not applicable on a stack. Remaining all operations comes under a stack operation. The following is a type of queue. So we have a priority queue, we have a last in first out queue, C is a both, none of the above. So C is the, which of the following is a type of a queue? Type of a queue is a priority queue. LIFO is a principle of a queue.
Yes.
LIFO is a principle of a queue. Priority queue is a type.
Okay.
They are asking, yeah. Next, fourth one, in a doubly linked list, each node contains data and one pointer, data and two pointers, doubly linked list. Okay.
Doubly linked is, I think, B.
Yeah, correct. Data and two pointers. Perfect answer. Then in a binary tree, a node can have at most how many children? Okay, binary tree. At most two children. 0
Okay.
or 1 and 2.
Yeah.
Next, sixth one. Which of the following hash table like collision resolution techniques uses a linked list to store collided keys? Like there are collision resolution techniques called as separate chaining method.
Okay.
That is the answer. And what is the time complexity of linear search? Order of?
Is it B?
No. Linear search. How many? Suppose n is equal to 5 elements you are giving, but you are searching element at the last position. If it is best case, order of 1. If average case, log of n. If the worst case, order of n. The answer is order of n. How many elements are there? That many times it can repeat the elements. That is called a linear search. So binary search requires that the array must be sorted. Yes.
Sorted.
Then only it can perform the.
Otherwise, you can't do a tree in a half an hour. Yeah.
Yes. Which of the following algorithms is not stable? So there is one algorithm called a stable sort. So it is performed. It is not stable. Means quick sort. Left side I with the pivot. Right side j with the pivot. At a time recursively performing. Steps in order to quickly achieve the answer. That's why it is called a quick sort.
Okay.
And what is the time complexity of selection sort? So there are elements like you can call it as order of n, order of log n, and order of n square. Means two for statements we are using in the selection sort.
Is it C? Yeah, C.
Yeah. Perfect. So next, merge sort uses which technique? Divide and conquer.
Divide and conquer, right?
Perfect answer. Divide and conquer approach. A graph which no cycle is called. See, if
No cycle means
graph
it's a simple.
with no cycles means no circles. That is called acyclic graph.
Okay.
You can call it as a acyclic graph. Then which graph traversal algorithm can be used to find the shortest path in an unweighted graph? See, we are using breadth first search, like a queue principle. First in, first out principle we are using. Okay. And what is the time complexity of breadth first search? Like number of vertices and edges. We used to have order of vertices plus number of edges. Okay. What is the base condition for most recursive algorithms? Recursive. It is a fixed value.
Okay.
And which data structures can be used to implement both stack and queue?
Linked list.
Yeah, we used to call linked list. List we are using. Which of the following is an application of stack? Parsing expression. Yeah, and job scheduling, network routing, all parsing expression.
Yep.
Okay. Then,
first in, first out.
Yeah, which of the following is a non-linear data structures? The array is a linear, linked list is a linear, and stack is a linear, graph is a non-linear data structures.
Yeah.
Perfect. Which of the following algorithms can work on disconnected graphs? Like both BFS and DFS, disconnected graphs. Then the last bit, in a complete binary tree, internal nodes have, see, exactly two children. Internal nodes having root node and child nodes. That means exactly left child is there, right child is there. That's why exactly two children. Then which data structure is used to implement a recursive algorithm? Recursive you can use for stack. Okay. And what is the time complex to insert an element into a stack? Order of 1 within 1 second. Which data structure is best suited for priority queue implementation? We are using binary heap. Binary heap is a complete binary tree, and there are two types of binary heap tree we are using, like max heap and mini heap. The root element is greater than of left and right childs. Sometimes root node is a minimum of left and right childs. Then in a single linked list, what is the time complexity of deleting a node, like order of n? And a complete binary tree with a node, n nodes has a height of, you can call it as an order of log n plus 1.
Okay.
In the worst case scenario, what is the time complexity of searching in a hash table?
Order of n.
So which searching algorithm works only on sorted arrays? Binary search.
Binary search.
Which of the following sorting algorithms is not a comparison sort?
Merge?
So yeah, we are using counting sort is a comparison.
Oh,
we
yeah.
are
Sorry. Yeah. Yeah.
Which type of graph contains no cycles?
Yes,
Cyclic graph. So which algorithm is most efficient in finding the shortest path in an unweighted graph?
Is it BFS?
First, yeah, BFS. So which data structure is optimal for implementing a least recently used cache? Doubly linked list with a hash table. So in a stack, the order in which elements come off is the reverse of the order they were added. A circular queue is also known as ring buffer. Which of the following is not a type of linked list? Single linked list, doubly linked list, circular linked list, quadruply. So quadruply. Binary search tree in order traversal of the nodes will result in ascending order the elements. Open addressing is also known as closed hashing. So what is the time complexity of a linear search algorithm in the worst case? Yeah, order of n. So what is the best case time complexity of the bubble sort algorithm is?
Order of 1.
Order of n. Then in a merge sort algorithm, what is the time complexity for merging two sorted halves? Order of n. In a directed acyclic graph DAG, the minimum number of vertices that must be there for it to contain a cycle is a direct acyclic graph cannot contain a cycle. So which of the following graph traversal algorithm can be used to find the shortest path in an unweighted graph? BFS only. In the quicksort algorithm, what is the time complexity in the worst case when the pivot chosen is always the smallest or largest element? Order of n square. So that's all, Sundar. Yeah, data structures. And you want to brush up database management and warehousing also?
Oh yeah, we can skip it if you like, or if you wanted to run it quickly, you can.
Yeah.
Whichever you feel.
Yeah, no problem. Can I take this class next tomorrow? Because tomorrow.
Oh, yeah, that's fine.
Yeah. So I'll stop here. Remaining 3 programs you try to execute and read all the concepts. I'm sharing this PPT to you. And tomorrow we can have this module 5th. Okay.
Okay, great. The TensorFlow, do you know what was the issue? Why I have
please show me. Yeah, please show me your screen so that I'll guide you how to install TensorFlow. I'm stopping my screen. You can share your screen so that I can help you out how to install TensorFlow.
Oh my God, everything is, hold on. Everything is hang. Let me see.
No problem. Please share your screen.
I can't click anything on the Skype.
Okay, so I will stop and do one thing. Pip install TensorFlow. That's all. What is the command?
I did. It didn't work.
What it is saying? Some upgradation or any problem it came. Can you stop the recording so that?
Yes.
Show me the screen after
1 second.
Quitting.
Can I join back? Okay,
Yeah.
because that would stop the recording. Okay, hold on. I can't click anything.
Okay, because it may be hanged.
Yes, somewhere we are talking.
Yeah.
Hello? It's not on. It's not loading.
Now it is shareable, your screen. Sundar?